Hello, welcome back to yet another episode of Stats with Mats. We going to do just a quick and dirty video today, simple review of the homework. Now, I asked you with this homework to conduct a bivariate correlation hypothesis test, and this referenced only material that we covered on Monday. However, the material on Wednesday will continue to be important. How to interpret regression coefficients and knowing what the components of the regression equation mean, that's going to be especially important once we get to actually the work next week, especially once we get to calculating two things, regression coefficients by hand, and then eventually interpreting multivariate equations. So if you have not watched that video, I encourage you to. Please make sure that you go ahead and do that. Anyway, as far as the material that I assigned to you today, you were asked, is there a relationship between X and Y, where X refers to a respondent's age and Y refers to a respondent's glucose levels. So we know what our variables are here. Keep in mind that X in a regression, in a correlation or a regression hypothesis test always refers to the independent variable, the thing that's affecting something else. And Y always refers to the dependent variable, always. So knowing that X refers to age and Y refers to glucose levels, right off the bat, I know immediately I'm hypothesizing that X has an effect on Y, even though that's not really quantifiable with the correlation coefficient equation. It's going to be something you want to keep in your head and constantly be thinking that way, because with regression, it's going to be very important. So X is as follows: 43, and when X equals 43, Y equals 99. When X equals 21, Y equals 65. When X equals 25, Y equals 79. When X equals 42, Y equals 75. When X equals 57, Y equals 87. And when X equals 52, Y equals 81. Now, if we look at our equation for the Pearson's product movement coefficient of R, I need X squared. I need the summation of the following: the summation of X squared, the summation of Y squared, the summation of XY, the summation of X squared, and the summation of Y squared. So I am going to create a table, and this was given to you here, with the columns corresponding to the things that you needed. So running through this, I added up my values of X: 43 plus 21 plus 25 plus 42 plus 57 plus 59. And I got the summation of X equaling 247. Then I took Y and added 99 to 65 to 79 to 75 to 87 to 81. And I got the summation of Y equaling 486. Third column of XY, I took each X and multiplied it by its corresponding Y. You can't go across pairs here. It has to always be within the pair. So 43 times 99 equals 4,257. Moving to the second row, 21 times 65 equals 1,365, so on and so forth down the line, and I reach a summation of XY equaling 20,485. For the fourth column, I took each value of X and squared it, and then summed it down that column to reach the summation of X squared equals 11,409. And then finally, the last thing I needed was the summation of Y squared, which, after squaring each individual observation for Y, I reached a summation of 40,022. That right there, that's the bulk of the work here. As for the conducting of the hypothesis test, let's look at our steps here. Step one, what do you know? I know that X equals age, and I know that Y equals glucose. Therefore, I need to phrase my hypotheses leading with the independent variable and ending with the dependent variable. I also know that I'm operating with 6 pairs of data here. So N equals 6 pairs of X and Y. In terms of my hypotheses, the null hypothesis is that there is no relationship between age and glucose. The alternate hypothesis is conversely that there is a relationship between age and glucose, that age does have an influence on the values of Y, in this case, corresponding to a respondent's glucose level. Nothing too crazy so far. For steps 3 and 4, I need to set my alpha level. You were specifically told to do this at the 0.05 alpha, so that's what I'm going to set my alpha level at, corresponding to 95% confidence. DF equals N minus 2, where N equals the pairs of data. So 6 minus 2 equals 4. Now, you probably didn't find that on your critical value sheet, but the critical R that you should be using is whatever the closest one to it that you see on this table, So I chose the critical R of 0.632. Because you haven't been asked if X leads to an increase in Y or an increase in X leads to a decrease in Y, I am going to set my critical value to be positive or negative. You will remember that Pearson's R can only ever range between +1 as the maximum and -1 as the minimum. It's got to be between that range, with 0 acting as the midpoint of absolutely no relationship. So my value here has to be, I have to calculate a Pearson's R that is either greater than 0.632 or less than -0.632. And what I have up here, the summation of X, summation of Y, summation of XY, the summation of X squared, and the summation of Y squared, I have everything I need to get to work with this equation, which is as follows. R is equal to 6 times 20,485 minus 246 times 486, divided by the square root of 6 times 11,409 minus 247 squared times 6 times 40,022 minus 486 squared. Having that, I will reduce that to 2,868, that's the reduced numerator, divided by 5,413.27. That is the reduced denominator. Do that division equation, and I have reached an observed value of R for 0.5298. Easy money. So I ask you, is 0.5298 greater than 0.632, or is it less than -0.632? The answer is it is not. 0.5298 is less than the positive version of this critical statistic. It is less than 0.632. So we fail to reject the null hypothesis. And our conclusion is that there is no statistically significant relationship between age and glucose levels. And that's what I got for you this week. Pearson's product movement coefficient, I don't think is very difficult. You just have to make that table. You got to work through it. You plug and play into the equation and you compare to the critical value. By this point, you're seeing that every hypothesis test undergoes the same type of logic and the same type of process. It's just a matter of how we have to alter our equations to suit the variables, the nature and the level of measurement of the variables that we have. Okay, so let's stop and let's take stock for a second about where we currently stand. We spent Monday discussing and today reviewing Pearson's product movement correlation coefficient. That allowed us to check for the strength of the relationship and whether it was significant between two interval level variables. And regression allowed us to actually quantify the magnitude of that effect, what the actual effect of an increase in X is upon Y, and to express that within its variables. Next week, we're going to dive into how to actually calculate that by hand. That's going to be on Monday. And then on Wednesday, we will also go forward and make our equation multivariate. Can we test the effect of multiple X's on Y simultaneously? You bet we can. It's just going to require some practice to understand the interpretation there. Anyway, that's what I got for you today. Thank you very much. I will be back on Monday, hopefully with more movie comments. Hopefully I can watch some TV this weekend. Thank you very much, and have a great weekend. Bye-bye.